So now that we've generated our project with the project setup UI, we are about to import it into an IDE. In this video, we are going to talk about how to do this in NetBeans. So let's fire up NetBeans. This video assumes that you installed all the required plugins and other things you need to compile for Android and so on and so forth. Please refer to the wiki or the last video. Okay, so now we are in NetBeans. Let's import the project. We go to File, Open Project. And then we navigate to our project's root folder. NetBeans is smart enough to detect that this is actually a Cradle project, so let's just open this project. The first time you do this, it may take a while because we download various dependencies and plugins and so on and so forth. In this case, we're already done, so let's expand the subprojects view. You can see there's a couple of projects we can import, so right-click on subprojects and say Open Subprojects. Now we have all of our different platform projects and the core project in NetBeans. Don't get confused by this little exclamation mark here, it's just NetBeans not understanding our Cradle definition 100%. So where's our code? Our code's in the core project and lives under the package we specified earlier using this as the main class. Our application here simply loads a texture from a file called libGDX and then clears the screen and draws that texture. Now the question is, where is this libGDX file located? That's in an assets folder. If you have an Android project, the assets folder has to be in the Android project. So in this case it's under Android assets. And here's our libGDX. If you don't have an Android project, the assets folder would be in the core and desktop project. So how do we run our application? Well, it depends on what platform we want to run it. For each platform, we have a so-called launcher class. So on the desktop, we have a desktop launcher, which instantiates an application and then runs our libGDX game. We have the same on Android, which is called an Android launcher. So just some Android-specific things, and then say initialize with this game. This is an Android application, and the same applies for HTML. We have an HTML launcher, and iOS, where we have an iOS launcher. These are pretty much the only platform-specific classes you need for a simple game. Everything else is contained in the core project. So to run your project on a specific platform, you have to actually execute these launchers. On a desktop, that's pretty simple. Just right-click the desktop project and select Run. This will now execute Cradle, which is smart enough to decipher that we actually want to run the desktop project via a simple Java invocation. And here's our project running on the desktop. To run it on Android, you right-click on the Android project, then go to Tasks, and you would usually select Install Debug or Install Release, depending on whatever you want. So your application gets installed to an emulator or a connected Android device. I will not do this in this video because it takes a while and I couldn't show you anything. Do not use the emulator for testing, it's really bad, it's slow, and the OpenGL emulation is actually not that good. So please get an Android device and test on an Android device. For iOS, you can also just right-click on the iOS project and then select the task. In this case, you want to launch it on a device or a simulator or another simulator, which is for the iPhone. So let's run our application on the iPhone simulator. This will invoke Cradle, which will then compile our application for iOS. That means it compiles all of the Java class files, which is about 3,000 files the first time you run this compilation step, and it will also compile your application class files. And the compilation is actually performed so that the class files get transformed into native code, which is then executed on a simulator. The first time you do this, this can take quite a while because there's a lot of things to compile. Subsequent compilations only recompile the files that you actually changed. So if we change our libGDX game file, only that would be recompiled and linked into a native executable. Down here you can see Cradle executing all the different steps it needs to execute to get this binary for the iPhone simulator. And here's our iPhone simulator, and the game's running on iOS. And here's a problem. In NetBeans, you cannot stop Cradle tasks. Since this Cradle task fired up the iPhone simulator, we have to close the iPhone simulator for the Cradle tasks to finish. So finally, I can show you how to run the HTML project, and that would work like this: right-click, and then go to Tasks and run the superdev task. As you saw with the iOS project, that's not a good idea, because you cannot cancel this iOS or HTML task. So instead, what we do to launch the HTML and iOS projects, at least that's what I would suggest to you, is open up a terminal and then launch the projects from the terminal. In order to do that, just go to your project, in this case download test, and then invoke Cradle itself. To do this on Linux and Mac, just invoke Cradle W. On Windows, you would open up cmd.exe and run cradlew.bat. In any case, you would then have to specify which project you want to run, in this case, for example, HTML, and the task that you want to invoke to run it, in this case, superdev. So this is how we start the HTML project. The HTML project will actually compile your Java code to JavaScript code, so you don't need Java on the end user's browser in form of a plugin, which is really nice. The only downside is that compiling from Java to JavaScript takes a little while. In this case, it's probably done in about 20 to 30 seconds from now. This HTML superdev task that we are executing will actually do more than just compile the Java to JavaScript. It will also spin up two servers. One server will serve the JavaScript and HTML files of our application, and the other server will wait for us to tell it to recompile our application. This is really nice because we can have a fast iteration cycle within the browser for our application. While this is compiling, I can tell you that you can also run the iOS project like this. So you just go to your project directory, and then you say Cradle W iOS, and then, for example, launch iPhone simulator. This will do exactly the same as we saw previously in NetBeans, except that in this case you will not have a zombie process. The reason why this doesn't work in NetBeans is because there's a bug in the Cradle API tools, Cradle tooling API, which hopefully gets resolved soon. So now we see that the HTML project's done compiling, and we can open up our browser and go to localhost 8080 HTML. And this is our game in the browser, which is pretty neat. So, next step is debugging our application. iOS cannot be debugged at the moment. It's a limitation of RoboVM, which will eventually be lifted. HTML, I'll show you in a bit. Desktop is pretty simple. Right-click, debug. This will spawn up Cradle again, which will run our application in debug mode. And then we can just simply set breakpoints, for example, here. And it should break in that breakpoint. Okay. You can do the same for Android, and debugging HTML is a little bit different. We do this in the browser. So, as you remember, we still have our server running here. That means we can also load our game in the browser. And to debug our game in the browser, we click on the superdev button and then click on compile. This will compile our application again on the background, and then serve us new JavaScript and HTML files. So now you can right-click here and say inspect element. This will work in Firefox as well if you have Firebug installed, and it will also work in Safari. Then go to sources, and here you can see the source code of our game. So it's in com, libGDX game client HTML launcher, or our main class. And this is really funky. It's Java code in your browser, and you can actually debug your Java code. Just set a breakpoint here, and then you can step, you can inspect variables here, and so on and so forth. And that's pretty much it. Now you might be interested in how to package your application for the different platforms. For that, we have a video, which is linked at the end of this video.